right, let's talk about scale drawings here for a minute. So if you read along with me, it says geometric constructions and scale drawings are closely related to each other in real life. For example, engineers and designers use geometric principles in constructions to make actual size drawings of objects like machine components or pieces for do-it-yourself assembly kits. However, it's not always possible to draw an object at its actual size. You may need to use a scale drawing that shows an object at a larger or smaller size. Floor plans and maps are examples of scale drawings. You might also find a scale drawing in the instructions for sewing a dress from a pattern. In this lesson, you will learn about scale so you can read and interpret scale drawings. So, for example, when they were building Ridge, they obviously didn't have, a life-size model of Ridge that would be the size of Ridge. They made floor plans, and they said, all right, so this floor is going to be 10 by 5, but they needed to make sure that they drew out a scale drawing that was a lot smaller than what it would actually be. So that's kind of what we're going to be talking about in this lesson. So, for example, it says using a photocopier, you want to reduce this poster to the smaller size shown. What % reduction should you choose? So what's happening here is you have this big poster and you're reducing it to this little poster size. And we want to figure out the scale factor is what we would multiply each of these sides by to get them to be these sides. So these are the ones that match up. 20 inches matches with 4 inches. 30 inches matches with 6 inches. So what do I need to multiply these ones by to get to these ones? There's a whole lot of arrows I just drew. So you may have noticed, like just by looking at it, you're probably thinking to yourself 5, because 6 times 5 is 30 and 4 times 5 is 20. But the problem is we're going from this bigger one to the smaller one, okay? So when we're doing scale factor, it should be your scale model needs to be divided by the actual. So in this one, we're actually putting the 6 over the 30, and we want to figure out, when we divide those, I end up with 1/5. So my scale factor is 1/5. If I take 30 and I multiply it by 1/5, I get 6, which is what I want. So because this is getting smaller, your scale factor is less than 1 whole. So what you want to do is divide these two numbers. You put scale model over actual, and when you divide them, you find your scale factor. And again, scale factor is what you're multiplying each of these dimensions by to get your new figure. So again, a reduction, your scale factor is going to be less than 1 or less than 100%. If it's being enlarged, your scale factor will be more than 1 or more than 100%. Reduction means it's getting smaller. Enlargement means it's getting bigger. All right, so take a look at this problem. Here's one trapezoid, and it's being enlarged to be this trapezoid, okay? So we're enlarging this time. That means our scale factor needs to be greater than 1 whole. So if we kind of stick to our scale model over our actual, and that's just what we're dividing, we want to put 7.8 and divide it by 2.6. And you should end up with something greater than 1 whole if it's being enlarged. So when I divide these out, 7.8 divided by 2.6, I get 3. So in this problem, my scale factor is 3 because 2.6 times 3 gives me 7.8. So a scale factor is what your original object is being multiplied by to get your scaled object, whether that be bigger or smaller. Okay, let's try this one. An artist made a painting of a water pitcher. Then the artist reduced the size of the painting. Find the scale factor of the reduction. So this is getting smaller, so our scale factor is probably going to be a fraction because it needs to be less than 1 whole. So if we take our scaled over our actual, so this is the scaled because it was reduced over our actual, and we reduce these so we can divide both of these by 4. We get 2/3. So our scale factor here is 2/3 because if I do 12 times 2/3, I get 24 over 3, which equals 8. That's what I want. What do I multiply this by to get to this? Another way we can think about this is if I have a picture or a drawing here, and this is a 10 by 9 picture, I can reduce it or enlarge it by using a scale factor. So let's say I wanted to reduce it by half. I wanted my scale factor to be half. What I would do is multiply both sides by half and create a new scale drawing. So 9 times half would be 4.5, or 4.5, and 10 times a half would be 5. So my reduction of this would be 1, 2, 3, 4.5, about by 5. 1, 2, 3, 4, 5. So this is my reduction of this, of my original. And if I didn't know what my scale factor was, I would put 5, because these two match, over 10, divide them, I end up getting half. So half is my scale factor, which is what I started with. Okay, so now let's say I wanted to enlarge it. You can choose any scale factor you want to enlarge. So let's say I wanted to double it. So that means I would multiply both by 2. My scale factor would be 2. And then I would need a rectangle that was 18 by 20. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 3, 6, 9, 12, 15, 16, 17, 18, 19, 20. There we go. This is an enlargement of my original. Kind of cut it off a little bit there. So this is 18 by 20. It's enlarged by a scale factor of 2.